Yet again, the universe is a boundless fractal made out of innumerable enormous bangs, each igniting the production of new domains. If you somehow happen to counsel the science coursebook distributed before 2006, you'd find Pluto recorded as one of the 9 planets in our planetary group. Anyway, that is not true anymore. Anywhere close to a long time back, the Global Galactic Association (IU) dubiously stripped Pluto of today planetary status, starting a discussion that go on yet the Asian is a long way from being done. NASA has as of late delivered probably the most clear pictures of Pluto at any point, caught reigniting revenue in the little frigid world. Every headway in innovation takes us further in our journey to investigate space, and we've made considerable progress since Apollo 11's memorable moon landing, yet the limitlessness of room implies that many inquiries stay unanswered. This is where NASA's momentous undertakings, for example, the James Webb Space Telescope (JWST), become an integral factor. While JWST tries to uncover its own secrets, it likewise expands upon NASA's prior missions, making a rich embroidery of disclosure. Perhaps of the greatest inquiry actually tormenting mainstream researchers is whether our ebb and flow comprehension of the universe, particularly occasions like the huge explosion, should be reconsidered. Considering new revelations, Pluto winds up at the focal point of this discussion. Because of the Hubble Space Telescope, we've had the option to plunge further into our sun-powered planetary group, and obviously reading material may before long need modification. Pluto, once downgraded to a bantam planet, might actually recapture its planetary status. The IU's 2006 choice was made with restricted information, yet the JWST has now given the pictorial proof that could make a huge difference for a really long time. 2 camps of thought have arisen. One accepts the IU rushed to downgrade Pluto, while the other acknowledged its new status as space investigation advances. Anyway, the discussion over Pluto's characterization keeps on stewing, with the JWST disclosures pushing it back into the spotlight. NASA's most memorable clear pictures of Pluto, caught during the New Skyline's main goal, are reworking how we might interpret this far-off world. In July 2015, New Skylines flew by Pluto and its moons, denoting whenever mankind first had at any point seen this far-off heavenly body very close. The information gathered was earth-shattering, uncovering insights regarding Pluto's surface and its moons, including its biggest satellite, Charon. This mission prepared for a more profound comprehension of Pluto and the Kuiper Belt, the far-off locale of our planetary group, where the bantam planet lives. New Skylines gave NASA 6.25 gigabytes of information, including staggering pictures of Pluto's surface, its satellites, and its geographical highlights. What it uncovered was completely progressive. Pluto can as of now not be named a planet, yet it is a long way from lethargic. Over the long run, its surface and barometrical circumstances have developed, introducing a test for researchers who presently should restore their models to represent these progressions. The mission's prosperity has laid the preparation for future investigations of far-off divine bodies, and with the appearance of the James Webb Space Telescope, the conceivable outcomes appear to be unfathomable. One of the main disclosures from New Skylines was the disclosure that Pluto has a harp, straightforwardly known as Sputnik Plana. This monstrous nitrogen glacial mass covers 1 million square miles and drives quite a bit of Pluto's land action. The heart-molded district is answerable for the reorientation of Pluto's twist hub in a cycle known as evident polar meander. Preceding the mission, researchers had no clue about that Pluto's bowl was inverse, its biggest moon, Charon. This reorientation has changed how we comprehend the bantam planet's collaboration with its satellites, showing the gigantic gravitational impact these bodies apply on each other. Yet that is not all. Underneath Pluto's frosty surface, falsehood, something much more phenomenal, a tremendous sea. The secret sea, joined with Sputnik Pia's colossal mass, is answerable for the reorientation of the bantam planet. The disclosure of fluid water on Pluto changes all that we assumed. We had some awareness of this far-off world and brings up new issues about its capability to hold on to life. While it could be too early to decide if Pluto's sea is tenable, this disclosure places it among other sea universes like Titan, Enceladus, and Europa, which are all remembered to can possibly uphold life. The disclosures on Pluto are only the start of what could be another period in planetary science. With the James Webb Space Telescope now going full bore, researchers are accessing remarkable information which will without a doubt keep on testing how we might interpret the universe. What makes JWST especially energizing is its capacity to look farther and more profound into space than any time in recent memory, opening the chance of finding new planetary frameworks, stars, and universes that might have slipped through the cracks with past advancements. The telescope is ready to give significantly more experiences into Pluto, yet in addition into the farthest reaches of our own planetary group and past. Pluto's renaming in 2006 by the Worldwide Cosmic Association as a bantam planet has been quite possibly of the most controversial subject in cosmology. Many have contended that the choice was made rashly with restricted information and obsolete standards. Now, with NASA's new leap forwards, including high-definition pictures, and an abundance of new information, those supporting for Pluto's restoration as a planet may at last have the proof they need. A few researchers have even recommended that the meaning of what comprises a planet ought to be returned to as how we might interpret divine bodies has advanced. Essentially, in the beyond couple of many years, one of the most convincing parts of this continuous discussion is the job that public discernment plays in logical order. Pluto holds a unique spot in the hearts of many space fans and easygoing stargazers. The same its downgrade in 2006 felt like an individual misfortune to the people who had grown up finding out about the 9 planets of the nearby planet group. Yet, science is truly advancing, and what we realize today might reshape the illustrations of tomorrow. If Pluto somehow managed to recover its planetary status, it would represent a logical triumph as well as the limit with regards to humankind to re-examine, rethink, and modify how it might interpret the universe. Past the close-to-home and philosophical ramifications, the new discoveries about Pluto have common-sense ramifications for planetary science as new skylines and JWST keep on giving new information. Researchers are better prepared to concentrate on the geography, air, and expected livability of Pluto as well as other divine bodies too. The idea that Pluto might have a subsurface sea, for instance, places it in another class of universes that could hold hints to the chance of extraterrestrial life in the event that water exists underneath Pluto's surface. What else could it stow away? Might there be different cycles working that we still can't seem to find? The solutions to these inquiries could have extensive ramifications for how we might interpret the nearby planet group. The revelation of a subsurface sea on Pluto, likewise, compels us to re-evaluate the role that frigid worlds play in our search for life. Previously, astrobiological research has focused on planets and moons closer to the Sun, where liquid water can exist on the surface. However, with each new mission, it becomes increasingly evident that life, if it exists elsewhere in the solar system, might thrive in environments we once believed were too harsh or too remote. Europa, one of Jupiter's moons, has been an excellent candidate for such studies. And now Pluto might join the ranks of these intriguing, potentially life-bearing worlds. As exciting as these discoveries are, they also highlight the limitations of our current technology. While the data gathered by New Horizons and JWST is groundbreaking, much of the information about Pluto and other distant objects remains incomplete. To gain a fuller understanding, future missions must go even farther, probe even deeper, and collect more detailed data. This means that investment in space exploration must continue to grow, ensuring we have the necessary tools to answer the questions raised by missions like New Horizons and JWST. One of the most challenging aspects of space exploration, especially when it comes to distant objects like Pluto, is resource allocation. Why invest millions or billions of dollars in studying a small icy world at the edge of the solar system when there are more immediate concerns, such as finding planets that might harbor life closer to home? This is a question that space agencies like NASA must grapple with as they plan future missions. However, as the New Horizons mission has demonstrated, exploring these distant worlds can yield unexpected and invaluable discoveries. The data gathered from Pluto may ultimately inform our understanding of the entire Kuiper Belt, a region that remains one of the least understood areas of the solar system. The search for life beyond Earth has long been a driving force behind NASA's missions. With the discovery of phosphorus in Enceladus Ocean, the possibility of extraterrestrial life has become even more plausible. Phosphorus, a key building block of DNA and RNA, is essential for life as we know it. While there is still no definitive evidence that Pluto's ocean could support life, the presence of water opens the door for further exploration. As we continue to probe the outer reaches of our solar system, missions like New Horizons and JWST are reshaping our understanding of distant worlds. The data collected so far has already forced scientists to reconsider long-held beliefs about Pluto and the other small bodies that inhabit the Kuiper Belt. While the debate over Pluto's planetary status may continue, one thing is certain: the dwarf planet is far more active and complex than we ever imagined, and its story is far from over. Pluto continues to surprise us in ways we never expected. While NASA is not actively probing ice-encrusted planets at the moment, Pluto is delivering remarkable discoveries that challenge our understanding of distant planets. One of the most astonishing findings is Pluto's unique form of volcanic activity. Let's break this down. Pluto, a planet that was demoted in status, not only has a heart-shaped region that reorients its spin axis and possibly an ocean beneath its crust but is also volcanically active. This has led a large group of scientists to fiercely criticize the International Astronomical Union for stripping Pluto of its planetary status, but that is a debate for another day. Right now, let's focus on the volcanic activity of this icy world. When we think of volcanoes, we typically picture scorching magma erupting from a mountain like the lava flows from Hawaiian volcanoes, which can reach temperatures as high as 1,250 degrees Celsius (2,200 degrees Fahrenheit). But Pluto's volcanoes couldn't be more different. Thanks to NASA's high-resolution imagery, we've learned that Pluto has its own unique type of volcanic activity called cryovolcanism. Instead of molten rock, frigid, slushy ice erupts from the planet's surface. This cryomagma, near freezing in temperature, pours across the surface before solidifying, creating new and unusual geological features. Pluto's iconic heart-shaped region, known as Sputnik Planitia, also plays a central role in this volcanic mystery. In the southern part of this region lie two towering mountains, Wright Mons and Pikar Mons, which scientists now believe are the mouths of cryovolcanoes. But that's not all. NASA's research has also revealed evidence of ice volcanoes in Pluto's western region, Viking Terra. This area shows deep cracks and ridges that may have formed due to the movement of supercold magma. These discoveries have led to significant changes in our understanding of the dwarf planet's geological activity. Pluto's largest moon, Charon, has also been the subject of incredible discoveries. Once considered less significant than moons like Saturn's Enceladus or Uranus' Miranda, Charon has now emerged as a key object of interest. The moon's surface features two radically different terrains: Vulcan Planum, a smooth plain in the south, and Oz Terra, a rugged terrain in the north. These contrasting landscapes suggest that Charon, too, might have an ocean beneath its icy crust, offering yet another target for future exploration. But it doesn't stop there. NASA's high-resolution imagery has revealed something unexpected. Pluto has dunes. Yes, you read that right, dunes. Unlike Earth's sand dunes, Pluto's are composed of methane-infused ice grains that have been eroded from the Sputnik Glacier. Despite the planet's weak gravity, thin atmosphere, and frozen surface, these dunes are scattered across its icy plains. As we stand on the brink of new discoveries with the James Webb Space Telescope, it's clear that Pluto's status as an inactive world is a thing of the past. The data we have gathered, just a few gigabytes, has unlocked vast possibilities, giving us a clearer picture of this fascinating distant world. As we venture further into the mysteries of our solar system, the role of smaller icy bodies like Pluto and its moons becomes increasingly significant. These worlds, often overlooked in the past, are now at the forefront of planetary science. The discovery of geological processes such as cryovolcanism on Pluto is reshaping our understanding of what makes an environment habitable, not just in terms of the presence of water but also in the types of energy sources that could exist in such distant locations. The fact that ice volcanism occurs on Pluto suggests a level of internal heat, potentially from tidal forces exerted by its moons or radioactive decay within its core. This opens new avenues for exploring how planets and moons far from the Sun could sustain complex processes similar to those on Earth. Moreover, Pluto's dynamic geology challenges long-held assumptions about the longevity of planetary bodies in the outer reaches of the solar system. The relatively young, active surface of Pluto, combined with the possibility of an ocean beneath its icy crust, indicates that these distant worlds may be far more dynamic than previously thought. The possibility of ongoing geological activity in places like the Kuiper Belt forces scientists to rethink the fate of other icy objects, many of which may harbor hidden oceans or volcanic activity of their own. The discovery of Pluto's complex atmosphere, including signs of seasonal changes, further complicates our understanding of how such distant objects can remain so active. With future missions focusing on even more distant Kuiper Belt objects, Pluto's place in our solar system remains a topic of ongoing debate. However, with the ever-advancing technological capabilities of spacecraft like JWST, we are closer than ever to answering fundamental questions about Pluto's true nature and the potential for life elsewhere. The more we learn about Pluto and its companions, the more we realize how much we have yet to discover, not just about the outer solar system but about the universe at large. Exploring these worlds may ultimately help us understand the fundamental conditions that make a planet or moon capable of supporting life, whether in our own solar system or beyond.